Hello everyone. In today's video we will discuss about communication between microservices. So here if we see microservices can communicate with each other with different patterns. Either they can communicate directly with each other or communication can happen via event bus. In this diagram we can see that front end calls microservices via HTTP calls and there is a API gateway in between. API gateway enables you to provide secure access to the backend services through a well-defined REST API. First, let's see synchronous communication. So synchronous communication happens via HTTP. We need synchronous communication when we get a call from the front end and it needs the response immediately. It can't wait for the response. As shown in this diagram, front end calls the order microservices and order microservices calls database and returns the response immediately and it will be displayed in the front end. So this is called synchronous communication and call is happening via HTTP protocol. Next type of communication is asynchronous communication. Asynchronous communication is needed when we have multiple microservices that need to communicate with each other and it takes time to do the processing. For example, here we have multiple microservices, ordering microservice, payment microservice, notification, ordering, stock, and shipping. So when an order is placed in an e-commerce website, payment microservices needs to payment the process, notification microservice needs to send the notification, ordering stock microservice will order the extra stock, and then shipping microservice will do the shipping related processing. So when the user will place the order, user should not wait for all this processing to happen in the background. So the communication should happen asynchronously. Let's see how the asynchronous communication happen via HTTP protocol. User places an order to the ordering microservice. So in place of returning a 200 response code, we can send a 202 accepted status code to the user. That means that order is accepted and in place of wait client needs to wait, we just send some kind of identifier to the front end that order is accepted and rest of the processing will go in the background. A Babel callback can also be used where ordering microservice will call to the specific URL that was provided when the order related processing is completed. Next, we will see that how asynchronous communication happen via messaging. So here we can see that there are multiple microservices and the communication is happening via a message broker. API 1 sends the message to the event bus and another microservices have subscribed to the event and they're listening to these messages. Here we can see that all the microservices are not communicating to the each other directly but via message broker and it is asynchronous communication because API 1 need not wait for the other APIs to process the message. Now let's see the types of messages in asynchronous communication. Two of the most important types of messages are commands and events. A command message is a request for a particular action to be performed. For an example, a notification needs to be sent, an email needs to be sent. So a command can be issued to another microservice and another microservice will perform the action. Usually command is listened only by single microservice. Events. Other type of message is an event. An event message is simply a way of announcing that something has happened and multiple microservices subscribe to an event. Let's see advantages of asynchronous communication. So main advantages of asynchronous communication are decoupling and scaling. When we use asynchronous communication, it completely decouples the microservices from each other. So instead of one service directly calling the next, it simply talks to the message broker. This means that if the second service is temporarily unavailable, then the first service is still able to function, and the second service can just process any queued up messages once it is online again. This approach is also very beneficial for supporting more advanced scaling patterns. If the number of unprocessed messages for a microservice is building up, we can scale that microservice out of the multiple instances to help work through the backlog of messages quickly. And many serverless hosting platforms do this automatically. That's it in this video. If you like the video, don't forget to like and subscribe the channel.